Welcome to your lesson on solving systems by substitution. You really have to love algebra to enjoy this topic. There's going to be a lot of just moving variables around, solving for y, solving for x, that kind of thing. Alright, to get the notes packet that I gave you, you're going to take notes in there and try some problems in there yourself as well. Let's begin with this sample problem. We have these two equations given to us, and it's going to ask us to solve this system two different ways. We're going to try to solve it both ways and see if we get the same answer, which we should. So first of all, it says solve by substituting equation 1 into equation 2. So here's equation 1, and it says substitute that into equation 2. So here's equation 2. Right? Notice that both equations are solved for y already. That means you can take this part, because since y here equals this, we can replace the y in the other equation with that portion. So that's what it means by substituting equation 1 into 2. So this part is going to replace this y here. And we rewrite this new equation like this. Once we've done the substitution, you notice that instead of having two variables, now the new equation only has one variable, so we can solve that. So to solve this, I'm going to do adding 2x on this side. And when I add 2x, it gets rid of it here. It makes 5x here. Then I'm going to subtract 1 on both sides. I have 5x equals 5. Then I'm going to divide by 5 on both sides, and x equals 1. So if x equals 1, we can now take that value into either one of the first two equations and solve for y. So I'm going to take this equation, the 3x plus 1, I'm going to put x equals 1 into here. Y equals 3 times 1 plus 1, and that is 4. So our solution is 1, 4. If you would graph those two equations, those two lines, they would meet at the point 1, 4. Okay, now let's try it a different way and make sure we can get to the same answer. It says solve equation 1 for x. So now this one is solved for y, but we're going to take it and rearrange it and solve for x. And then we're going to substitute that into the second equation. So here's the first equation again. If I'm trying to solve this for x, I'm going to move this 1 over to this side. So I'll have 3x equals y minus 1, because when that goes over there, it's y minus 1. Then I'm going to divide by 3 so that I have a solution for x. When I divide by 3, I have to divide this entire side by 3. This is one way to write this. You could have also written y over 3 minus 1/3, but you can keep it as one fraction like this. That's okay. Now it says substitute this into equation 2. So here's the other equation. We're going to take this x value now and put it in here. So over here, we replaced the y with this portion. Over here, now we have this solve for x. We can put this into this x right here. So once you make that substitution, you have y equals -2, and then -2 times this, all of that is x. So that has replaced the x portion here. Now this part here, you have to multiply through. So I take -2 times y and -2 times -1. So -2 times y is -2, -2 times -1 is 2. I'm left with this. To solve this, maybe we can get rid of the 3 first. So you can multiply every piece by 3. Multiply this by 3, multiply this all by 3, which will cancel away this 3, and multiply this by 3 also, which makes this 18. So again, notice the 3 in the denominator is gone now. Now we can add 2y on this side to get rid of this 2y. And then this makes 20, then divide by 5 makes 4. Now notice that is the same answer here. So basically this gets us our solution. We're done if we want to just solve the equations, but we're doing this basically to practice your algebra, and making sure we can get to the same answer. So here's y equals 4. Now that can be substituted in here. So if you put a 4 in here, you'll get 4 minus 1 divided by 3, or into this equation, either way. And when you solve that, you get x equals 1, which confirms the other part of that solution, the x part. Alright, so both ways led to the same answer. That's good. One way clearly is easier than another, but again, we're practicing some algebra. So now try this one, see how you do, and then check your answer. Alright, now we have a different situation. We have these two equations. They're no longer in y equals mx plus b form. They're in this form called standard form. We have x and y. And to solve this, well, you have a choice. To do substitution, you need to have something solved for y or something solved for x. When you look at these two here, we're going to try. You could solve for this x in this equation and then substitute that in here. or you could solve for this y and then substitute that into here, or you can look at this equation, you can solve for this x, or you can solve for this y. So basically, anytime you have a system like this, you have four choices. You can solve for this one, this one, this one, or this one, and then make the substitution. So usually our goal is to look at which one would be the easiest to solve for. Well, let's try two different ways. So in this sample, we're going to try to solve 1 for y. I'm going to take this equation and solve for y, because that looks pretty easy to solve. To get y alone here, all we have to do is get rid of this 4x. So here's that equation. All I had to do is add 4x on both sides to get this. That was easy. Probably of the four variables that are there, that was probably the easiest one to solve for, because there's just one step to there. All right, now I take that. Here's my second equation. I can take this y value, y equals this, and replace this y with what I had just found out y is right there. So there's a substitution made into that, where it had minus y, now it has minus this portion. Make sure you keep the parentheses around that, that's important. So now you multiply this negative through both of these. So this becomes negative 4x, and this becomes negative 6. All right, so we have negative 5x minus 4x, which is negative 9x here. And then this minus makes this 6 a negative also. Right, now I'm going to add 6 on both sides. So negative 9x equals 27. Then I'm going to divide by negative 9 to get x equals negative 3. Once I know x, you can take that and put it back into the original equation here to solve for y. So actually, I didn't even put it in this one. I put it in this one. All right, so x goes in there, negative 3, and that makes it positive 12 plus y equals 6. We're going to subtract 12 from both sides and get y equals negative 6. So our solution is negative 3, negative 6. That's where those two lines, if you graph these, would intersect at this point. All right, now let's try a different way. We're going to solve equation 2 for y. So I'm going to look at this one. It's also pretty easy to solve for this y. So there's equation 2. I moved that y to this side, and it became positive. Now I'm going to move the 21 to that side to make it negative 21. I've solved for y. Now I'm going to substitute that into equation 1. So take this, put it into this equation, which is equation 1. We know y is this, so we're going to replace this y with all of that. So there's the substitution that's been made. That y equation that we solve here, that y value, is replacing this y here. Now we have negative 4x and negative 5x makes negative 9x. There's negative 21 equals 6. I'm going to add 21 to this side. Now I'm going to divide by negative 9, and I get negative 3 for x. So again, that matches what we got here. So once again, we're trying it one way and trying it a different way just to make sure we can do our algebra correctly, get some good practice with algebra, and hopefully get to the same answer. So negative 3. And then if that is put into this equation, that negative 3, you will get the same y value. So same solution, good. It should be, of course. All right, in the sample, there's two more to do, right? It's getting you to try all four ways, so that's why this problem gets a little more complicated. Now it's going to take equation 1, it says, and solve it for x. Before we solve this for y, now we're going to try solving for x. All right, so take that equation, minus y to get that there. Then we're going to divide by negative 4 to get rid of this negative 4 here. So this whole side has been divided by negative 4. Now that we know x is this, we take the second equation, take that x value, put it into there. So again, that x there has been replaced with what we found x equals here. There it is. Now multiplying that through, that negative 5 will multiply both top parts. So negative 30 and positive 5y divided by negative 4. Now get rid of the fraction by multiplying by negative 4. So this multiplied by negative 4 becomes just a numerator. The bottom's gone. This becomes 4y. And this becomes negative 84. Now over here we have 9y, negative 30 minus or plus 9y. Then I'm going to add 30, divide by 9 on both sides. I get y equals negative 6. Once you have y, you can put it into either equation. I'm going to put it into this one, put a y value of negative 6 in here. and then solve for x. X is -3. So our solution is -3, -6. Again, the same solution. We're getting the same answer no matter what we try. And finally, let's try it one last way. Solve equation 2 for x. So this equation will be solved for x. So here's equation 2. We've already solved it for y before. Now we're going to solve it for x. And first, I move the y over to there. Now I'm going to divide by -5 to get rid of this 5 here. So x equals this divided by -5. So now I have this fraction, which I can substitute for x in the other equation. So here's the other equation. This x will be replaced by all of this. So here's that substitution. That x has been replaced. Now we multiply -4 times this and this. -4y minus 84 over -5. That remains the same. Now to get rid of this fraction, we're going to multiply everything by -5, so that -5 can be cancelled away. So that -5 is gone. This remains. This has been multiplied by -5, and this has been multiplied by -5 also. Now we can combine the -4 and -5, makes -9y, and I also added 84 to here in one step, makes 54, then divided by -9, y equals -6. And that leads to the same solution as well. So we tried all 4 ways. It all led to the same solution. Obviously, the first 2 ways are much easier than the second 2 ways because the second 2 approaches here led to these fractions. So right now we're just practicing and getting a feel for things. In the future, you can choose the method, or you can choose which of the 4 you want to solve for first and decide which is you think is going to be most efficient. So this is the one for you to try. If this is kind of intimidating for you, well, give it a try. Let's see how you do. But if doing all 4 ways is a little too hard, then I would suggest just trying what you think is the easiest way, which is maybe solving for this x right here first, which would be this one here. And then just moving straight on to the other side of the worksheet, which is all these systems, and you just have to get the solutions. The solutions are given to you, you just have to get there, all right? And in these cases, you can try all 4 ways, or you can just try the one way that you think is most efficient. For example, in this first one here, number 3, this is already solved for y. So all you have to do is take that and substitute it in here for this y, and then go ahead and solve from there. All right, this one, for example, also solve for y. So this here is going to go into here, and then you can solve. This one also has a y value. This one does too. And as it goes on, you just take a look at them. They get harder than that. But in some of them, just to make a decision, which variable of the 4 different variables do you want to solve for first? One will be easier than the others, and then continue from there. All right, practice hard, improve your algebra through this exercise, and enjoy solving systems.